Video 2 here on adding and subtracting polynomials. Here we go. How is adding polynomials like adding whole numbers? So we are going to compare, right, adding these two 3-digit numbers, 123 plus 405, to these two polynomials, x squared plus 2x plus 3 plus 4x squared plus 5. So let's go back to first and second grade. 123 plus 405. You line up your ones, your tenths, your hundredths. You go 3 plus 5 is 8. 2 plus 0 is 2. 1 plus 4 is 5. And there we go, 528. Well, the same thing here. We can line up our polynomials. X squared plus 2x plus 3. And then notice that this second polynomial only has two terms. It's a binomial. It's missing the x term, right? So line up the 4x squared, and then don't put the plus 5 here, put the plus 5 at the end, right? Now, if you want to, you can put in a plus 0x as a placeholder, but you don't need to. And now let's combine here. 3 plus 5 is 8. 2 plus 0 is 2. 1 plus 4 is 5x squared. And notice that the coefficients of your terms, 5, 2, and 8, are the numbers of this 3-digit number. So adding polynomials is very similar to adding whole numbers. Just make sure you have your like terms lined up. Okay, so let's add these two polynomials. What is the sum? Sum means addition. Now notice we have two types of methods. We're going to do vertically and then horizontally. So vertically is just what we just did, right? So we're going to line up 4x squared plus 2x minus 3. I'm going to put the 3x squared underneath here. I'm going to leave the plus 2x empty, this space empty, and plus 6 there. Add down, negative 3 and positive 6 is positive 3. The 2x just comes down, and 4 plus 3 is 7x squared. So there's one way to do it, 7x squared plus 2x plus 3. Now the other way is doing it horizontally. I like horizontally because I don't usually have to rewrite the problem. Right now, you guys are doing it on Savas, so you will have to write the problem every time. So we'll do 4x squared plus 2x minus 3 plus 3x squared plus 6. Now, when you're doing this, because you're adding and there's no numbers in front of the parentheses, these parentheses don't matter. Right? So I'll use blue. They don't matter. And now we just combine our 4x squared and our 3x squared, the highest terms. That's 7x squared. Then we combine our next degree highest is 2x by itself, so it's just 2x. And then finally our constants, which again have a degree of 0, negative 3, and positive 6 is positive 3. And again, no matter how you slice it, if you slice it vertically or horizontally, you get the same answer. So let's take a look at now the difference, right? So what is the difference between these two polynomials? Right? So now we're subtracting. So again, method 1, the vertical method. So x squared plus 3x minus 2. And then we have 3x squared plus 5x minus 8. But now we're subtracting. And subtraction works a little bit different, right? Because subtraction is it's not going to just change the first sign of this and make it a minus 3x. It's going to change every sign. So we actually should put the second parenthesis, the thing following the negative sign, in parentheses. And we should actually think of this as distributing a negative 1. We're going to take this second polynomial and distribute a negative 1 to all three parts. So the top one stays the same. But now the bottom one is going to change all of the signs. Negative 3x squared, negative 5x, and positive 8. All the signs change. And now it turns into an addition problem. Now you just combine like terms because you've already taken into account the subtraction. So negative 2 and 8 is positive 6. Positive 3 and negative 5 is negative 2x. And then 6 minus 3 is 3x squared. 3x squared minus 2x plus 6. That's an x if you can't read that. Sorry about that. So when you do subtraction, you need to make sure you distribute the negative sign. Okay, so now we're going to do it horizontally. So again, I like horizontally because in this problem, I would not rewrite it. I would just take this negative, I'd pretend this is a -1, and I would distribute it to all three terms. So the first parentheses can be dropped, and you just rewrite the problem. So it's just 6x squared plus 3x minus 2. But now you change all the signs of the second parenthesis. -3x squared, -5x, +8. And now I'll combine my 6x squared and my -3x squared to get 3x squared. I'll combine my 3x and my -5x to get -2x. I'll combine my -2 and my +8 to get +6. And there is your difference between those two polynomials. Now, we talked about this idea earlier in the year, but this idea of closure. So closure is this idea of like if we have a set of numbers and we add or subtract or multiply, divide, do we get more of those type of numbers? Well, these are polynomials. And you'll notice that when you add or subtract polynomials, you get another polynomial. This is closure, right? This means that polynomials are closed under addition and subtraction because the result is another polynomial. So that's just a little tidbit about closure, another vocab word. All right, one more question in regards to adding and subtracting polynomials, a little bit of a word problem here. So it says here that an engineer is reviewing the layout of a solar farm, right? These are popping up more and more as we go into the 21st century and all the different types of energy sources. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of the farm's solar panels? So it says that the total area of a large solar panel is represented by 32x squared plus 384x, small 4x squared plus 24x, and medium 33x squared plus 272x. So this is the large, this is the small, and this is the medium. So to find the total area, what we need to do is take these 3 areas and add them together, combine them, because we want the total area, and that typically means sum. So I'm going to take the small ones first because it lists small first. Now notice in here it has the 4, the 33, and the 32. I was confused on whether I had to incorporate those, but they're already incorporated. Notice that for the small panels you have a 4x squared, right? So it's already located in there. So we're going to take 4x squared plus 24x. We're going to add that to, now my medium, again with this 33, we're going to add that to 33x squared plus 272x. And then I don't have room horizontally, so I'm going to put it right here, add. And for my large with the 32, notice it's already there, 32x squared plus 384x. And again, because we're adding, the parentheses don't really matter. I was just trying to keep them linked together. And now we just combine our like terms. Notice that we have 1, 2, 3 x squared terms. So 4x squared, 33, that's 37, plus 32 is 69x squared. And then if we add the x terms, 24 and 272, that's 296. 296 and 384, that's a big number that I have to use a calculator for, and I already did. That is 680x. And this would be the expression for the total area. If you want to be clever, it would be in units squared, right? You could put that in parentheses if you want to, because area is in square units. It does not give us units here. Perfect. Awesome. So hopefully this section goes well with adding and subtracting polynomials. All right, thanks for watching.